Hello everyone and welcome back. My name is Mr. Covalt, and in this video we're going to be going over how to create buffers, what buffers are, and what the methods of creating buffers are. So let's get into this. Okay, so first, what are buffers? Buffers are basically solutions that can resist the changes in pH when you add a small amount of strong acid or strong base to them. So basically that's all a buffer is, something that resists the pH change when you add acid or base to them. Okay, so what one of the characteristics of this is that they are made up of a reasonably large amount or quantities of both the weak acid and its conjugate base. So in order to have a buffer, you need a weak acid and you need its conjugate base mixed together in the same solution, and you have to have relatively large amounts of those. So having a little bit of each one doesn't really make for a good buffer. But if you have large amounts of the conjugate acid and its weak base, or weak base and its conjugate acid, or weak acid and its conjugate base, then that'll be a good buffer. And I'll explain why. Because you have to, in order to understand why you have to have large amounts, you kind of have to understand like how they work. So basically, I set the stage. So you've got a vat of, or a beaker of solution. It's supposed to be a buffer. So you've got a mixture of, say, for example, HNO2, which is nitrous acid, and its conjugate base is the nitrite ion. So if you have a mixture of that in a beaker, how would that react with a strong acid or a strong base? So when you add a strong acid to it, it's going to neutralize. It's going to be neutralized by the base, or by the buffer. How though? So if you add H plus to the HNO2 NO2 minus buffer, the nitrous acid nitrite buffer system, the NO2 minus, the nitrate ions, will capture the H plus. So, excuse me. So for a strong acid, basically to review, a strong acid is an acid when you put it into the solution or when you put it into water, it's going to ionize completely in water, almost practically 100%. So whatever strong acid you put in there, basically it's going to dissociate, it's going to be ionized into H plus ions, and that's the key species that is reactive, is H plus. So you're putting in a strong acid, and then that's producing all of this H plus ions. The H plus ions will then react with the nitrite ions in this particular buffer, or the conjugate base of the buffer, and that's going to form and result in forming the weak acid back, right? So basically, you've replaced the strong acid, H plus, with a weaker acid, HNO2. And if you remember about weak acids are acids that hardly dissociate in water compared to strong acids. A very, very tiny bit will dissociate or ionize in water. Why is that? It's because the bonding here is so strong that they like to stick together. So the nitrite ion will not easily let go of that H, the hydrogen in the HNO2. So it will hold on to it more strongly, and therefore it's not going to give off the H plus. And so therefore you're swapping a strong acid with a weaker acid that has a less effect on the pH. So therefore, although when you add the strong acid into the buffer, you will change the pH a little bit, but not as much if you actually put, say, for example, if you put the strong acid in water, the pH would change quite a bit. But if you throw it in the same amount of acid, the same strong acid into a buffer, you'll get a tiny change in the pH compared to the large pH change that you would get if you threw it in water or a solution that was not a buffer. Okay, what about neutralizing strong bases? So strong bases, again, for a strong base, that's typically going to be something that has a hydroxide ion in it. And again, it is going to dissociate in water relatively easily. So 100% dissociation of water for the strong bases. And so basically you're adding OH minus ions to the water. And so what happens is that when you add the hydroxide ion to the buffer, again, we're dealing with the nitrous acid nitrite ion buffer. The hydroxide is going to react with the HNO3 this time. So it's going to go in the reverse direction, right? When we're neutralizing strong acids, the acid is going to react with the nitrite, the conjugate base, and then it's going to reform the weak acid. In this case, the hydroxide is going to react with the weak acid in the buffer, and it's going to then form water. Water is a neutral substance, it's unreactive, so that's not going to do anything. So you're taking the OH minus concentration and it's becoming water, and then you're left also behind is the nitrite ion, which is a weaker base. So in effect, you're kind of replacing the strong base with water and a weaker base. And again, because you're creating a more weaker base, the pH is going to shift a little bit, but not nearly as much as you would expect if you threw the same strong base into water or a non-buffer. Okay, so that's basically how the buffers work. Now let's talk about two methods of creating buffers. Well, how do you create a buffer? What's the easiest way? What are some ways that you might easily create a buffer? And so I'm going to talk about that next. Okay, so let's talk about how to create a buffer. So again, as I said, there are two methods. The first method is pretty straightforward. All you do is you take a beaker and you add some of each of the two species, the acid and its conjugate base, into the beaker, and voila, you have your buffer, right? So remember, a buffer must have large or relatively large amounts of each of the species in it, right? And the best buffer you can have is equal amounts, right? So if I could add equal amounts of both the acid and its conjugate base together into the beaker, then I would have my buffer. So for example, here I have acetic acid, C2H3O2. It's a solution, and then I can add to that acetic acid solution solid sodium acetate. So sodium acetate, here we have the salt of the conjugate base, we have sodium ions, and then we have the acetate ion, which is the conjugate base of the acetic acid, right? So what I could do is I could take a few milliliters of the acid, right? So take a few milliliters of this weak acid, add a few grams of the sodium acetate, the conjugate base, and then I could fill it up and add like 50 milliliters or 100 milliliters of water, and then I have my base, and then again I would have my buffer, right? So in that case, I made it using the first method. The second method that you can use to create your buffer is known as the partial neutralization method. And as the name suggests, basically what you do is you start with only one species in your container, and then you cause that species to react in some way in order to produce the other species. But you're going to react it with a specific amount. You don't want to react the whole thing, because then you just go all the way to the other side, right? So you'll have one species to begin with, and then you'll just have most of the other species to end with. So you target a specific amount to react, so that way you're creating a specific amount of the other species, in order to have equal amounts of it, or both amounts of it. And again, like I said, the best buffer is going to be where you have equal amounts of both your acid, your weak acid, and the conjugate base, right? So those are the two methods. And so you could use either one. In my next video, I will show a couple of example problems where I show you how to make the solution. I'm not going to actually make it in front of you, but we'll go over some example problems that require you to make the buffer, and then we'll figure out what the pH of those buffers are. And so that's it for this video, and I thank you for joining me. Please, like my video, hit that like button down there. If you do, also make sure you subscribe to my channel, hit that notification bell up there somewhere, so that way you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.